Integration by substitution. The substitution technique is used in integrating a composite function, or f of g of x. Integrating function is finding the antiderivative of the function. Seeing the composite function that has led to a derivative is often less than intuitive. Substitution helps. Here we must look for a function of another function and the derivative of the function that is the variable in the first function. So we have f of g of x, and what we're actually going to do is look at the f form, and then we're going to look at the derivative of g of x. This becomes easy after getting used to the process. Going over an example is the best approach. Find the integral 3x squared times the square root of x cubed minus 9 dx. Here we are looking for the integral of f of g of x dg of x dx with respect to x. Notice if g of x equals x cubed minus 7, dg of x dx equals 3x squared. So we're going to let u equal x cubed minus 9. du is du dx dx is 3x squared dx. So we're going to substitute using u and du. This will give us u to the 1/2 power, and du is the integral of u to the 1/2 dx. Which is u to the 3/2 divided by 3/2. We use the power rule. Right? The integral of u to a power is power plus 1 divided by the power plus 1 plus the constant of integration. Then we would substitute back for u. U is x cubed plus 9. So we get, just flipping this denominator, 2/3, x cubed plus 9 to the 3/2 plus c. Always substitute back, find the answer with the original variable. Sometimes it's necessary to adjust for a constant multiplier. Find the integral of x e to the x squared dx. Choose u equals square. Then du equals 2x dx. Take care of the needed 2, multiply by 2/2. So we have the integral of 2/2, which is a form of 1, so we can always do that. X e to the x squared dx, or 1/2 e to the u du. Now, since the integral of e to the u is itself, we get 1/2 e to the u, which is 1/2 e to the x squared. And this is going to be, of course, with the plus c, constant of integration. Notice u equals x squared, du equals 2x e to the x squared dx gives 1/2 integral du, or 1/2 u plus c, which is 1/2 e to the x squared plus c. And it also gets us the same answer. So choosing your u and finding the corresponding du is not unique. Sometimes there's more than one way of getting to the same answer, which makes it a little difficult for students because there's no formula that says Here's what u is. Here's what du is. It's your experience with derivatives to find du and the form of a u that you can handle. A definite integral, integration over an interval. When taking a definite integral, there are two options. Change the limits of integration to the values of u, or use the limits of integration as given only after changing back to the final function of x. So we're going to find the integral from 1 to 2 x over square root of x squared plus 3 dx. Here we're going to let u equal x squared plus 3, du equals 2x dx. So we have the integral from 1 to 2 of x over square root of x squared plus 3 dx. Now, here is our 1/2 because we need 2, so we're going to have to multiply by 1, 2 over 2. Part of that's going into the du, and the other part will be here. And when x is 1, u is 4, so we change the limit. When x is 2, 2 squared plus 3 is 7. And so what we have is 1/2 the integral from 4 to 7, u to the negative 1/2 du, or 1/2. Now, here we're going to raise this to the plus 1 power, u to the minus 1/2 plus 1 is u to the 1/2. And we're going to divide that by 1/2, or flipping it around, we got 2 over 1. And this bar indicates, so the lower limit is below it, the upper limit is above it. So we're going to subtract the lower limit from the upper. So we're going to get x squared plus 3 to the 1/2 from 1 to 2, or the square root of 7 minus 2. And when we put the 1 in, we're going to have 4, and the square root of 4 is 2. Here's the constant of integration with definite integral.